You're back to get more help on how to find mole ratios. And in this video, we're going to find all the possible mole ratios for the reactions that are in the examples. Number one, we must have a balanced chemical equation. Number two, we're going to find all possible combinations, and the top and bottom location is going to make a difference for us. So we have to find all the combinations, and top and bottom matters. I find that following a plan is more efficient than making random combinations to help us to keep track of what we've done and where we need to go. Mole ratios, once again, are used to convert from one substance to a second substance. So in a reaction stoichiometry problem, it helps us to go from substance A to substance B. This example is different than what we saw in the previous video because now we have actual substances. And in this balanced chemical equation we have here, it says 2 moles of hydrogen react with 1 mole of oxygen to produce 2 molecules of water. Now we're going to come up with all of the possible mole ratios. So I'm going to underline my plan. I'm going to start with hydrogen gas because I always start with the compound that is on the left side of the equation, and then I make combinations with all of the other compounds, but I go in order, working to the right and then to the far right. So it says here we have 2 moles of hydrogen, and the relationship we have here is if we have 2 moles of hydrogen, we need 1 mole of oxygen. Now in front of oxygen there is nothing, but remember when we write nothing that means there is a 1. Now I make my second combination, 2 moles of H2, and we see up here in the balanced chemical equation that that is related to 2 moles of H2O. Now I've made all of my combinations with hydrogen gas with the other compounds. Now I can do it with oxygen. I need to switch colors here for you. So now I'm going to do oxygen, and I'm going to do it with water because I've already done oxygen with hydrogen. So the only other thing to combine it with now is water. So 1 mole of O2 is related to 2 moles of H2O. Now I've done all the possible combinations. I can't do another combination with water and some other compound because I've already done water with the other two. So that would just be redundant, and we don't want to do redundant combinations. Now hopefully you remember from the previous video, to get the other 3 mole ratios, we just have to take the reciprocal of each one of these. So 1 mole of O2 for every 2 moles of H2, 2 moles of H2O for every 2 moles of H2, and 2 moles of H2O for every 1 mole of O2. We have 6 total combinations. Remember from the previous video, we take the number of substances, which in this case happens to be 3. We multiply it by a number that is 1 less than 3 in this case, 2, which means we should have 6 combinations. We have 6 combinations. We've done them all. Now we have this example. We have iron reacting with oxygen to produce iron 3 oxide. We're going to make combinations just as we did before. I like to start with the compound on the far left. I make combinations with all of the other compounds in order, and that helps me keep track of what I have done. So 4 moles of iron are related to 3 moles of oxygen. 4 moles of iron are related to 2 moles of iron 3 oxide. Those are the possible combinations with iron. So now I do my other combination, which involves oxygen. So 3 moles of oxygen for every 2 moles of iron 3 oxide. Now if we do the math again, we have 3 substances. 3 minus 1 is 2, so we multiply by 2. So that means we should have 6 total combinations. And the other 3 combinations are the reciprocals. So we have 3 moles of O2 for every 4 moles of iron. We have 2 moles of iron 3 oxide for every 4 moles of iron, and 2 moles of iron 3 oxide for every 3 moles of oxygen. Well, I hope this video has been helpful, and I hope you have a great day.